Now, any question on the homework? So, up to this point, we've gone over several different ways to solve quadratics. First one we went over was factoring. When we multiply two things together equals 0, one of them must be 0, set them to equal to 0 and solve. The second method was graphing. We graphed them where they cross the x-axis. Was our solutions. It's what value of x made the function equal 0. And the third one that we went over was our square root method. And these are the three that we went over first. Really part of 3.3. We kind of did those all together, and we have that there. Now, with all these here, they all had some kind of drawback to them. If it wasn't factorable, we couldn't solve it by factoring. If it didn't cross the x-axis, we couldn't solve it by graphing. And square root method worked in some cases, but not in all, because if we had a middle term, technically square root method didn't work. But the way we went over yesterday, completing the square worked in every single case. No matter what the quadratic is, we can use completing the square to solve it. The other, that's the one we're going to do today, is the quadratic formula. The quadratic formula will work every single time. And that's what we're looking at today. Most like the quadratic formula better than completing the square. I've had a few that like completing the square more than the quadratic formula. Now the quadratic formula is this right here. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And all we got to do is plug in the values of a, b, and c. And the other part of it is making sure that the equation equals 0. Now I can go more into doing this, but I think it'll be better just to see how one works. So here, first thing we need to do is get the equation equal to 0. So looking at this here, x squared plus 3x equals 5. What do we need to do to get it equal to 0? We need a minus 5 from both sides. Yes. And we subtract 5 from both sides, we get x squared plus 3x minus 5 is equal to 0. Now we are relating this to our ax squared plus bx plus c equals 0. Now for us here, we're going to find the values of a, b, and c. The value of a in this case would be, the value of b is, and the value of c is negative 5. So we take the sign with it. Since there's not a sign in front of x squared, it's positive 1. Our plus 3 is positive 3. Minus 5 would give us negative 5. You're welcome. Now the equation is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Now we need to plug in the values of a, b, and c into this equation. Well, the value of b is what? 3. So we have negative 3 plus or minus square root of b squared, so we'd have 3 squared minus 4 times a, well a is, c is negative 5, all over 2 times a, which would be 2 times 1. So what we've done so far is plugged in a, b, and c. Questions on this here? Now at this point, we're going to do some simplifying. Well, negative 3 is negative 3. The denominator, 2 times 1 is 2. Now we could plug in the square root of 3 squared minus 4 times 1 times negative 5. But if what's inside that radical is negative, the 30xs, the yellow calculator, will throw it out because it can't take the square root of a negative, which means we'll have to delete the radical, type it all in again, and see what we get. The graphing calculator will take I. It will simplify in terms of I. But if the radical does not simplify, it's not a perfect square, it's going to turn it into a decimal, and we'll have to retype it back in. So what I normally do is just take everything inside the radical. So we'll clear all that out, and we'll say 3 squared minus 4 times 1 times negative 5. So I'll type the whole thing in without a radical and get 29. So what we're saying is x is equal to negative 3 plus or minus the square root of 29 over 2. Now, I can say second square root 29. It tells us it is square root of 29, so it does not reduce, which means that's the answer. Probably something like it. Miss Kendall used to have this above her door for a while. Had the formula anyways. Questions on this here? Be ready to look at another one. 3x squared plus 4x equals 10. Our first main step is getting this equal to 0. So we would minus 10. Giving us 3x squared plus 4x minus 10 is equal to 0. Now the value of A is, B is, C is negative 10. Here we don't need it because we needed it for completing the square because we needed to make it a perfect square trinomial that then we could factor to a set of parentheses squared. Here, we're just plugging it in. So negative b, well, our b value is 4, plus or minus the square root of 4 squared minus 4 times 3 times negative 10, all over 2 times 3. So for this here, we're plugging the values of a, b, and questions on how we got to this point here. Well, our negative 4 becomes, well, negative 4. Our 2 times 3 is 6. Now we can plug everything inside the radical into the calculator. 4 squared minus 4 times 3 times negative 10, which is 136. Now we can take the square root of it, which is negative 4 plus or minus 2 square root of 34 over 6. I didn't say it on the last one because it didn't have it. This one, do the two numerators and the denominator, do all three of those spots have a common factor? They have a common factor of? So in most cases, we would need to simplify this out. There's a little bit easier way to do it. I'm going to pick the positive or negative case. I can't pick both because the calculator won't do both at the same time. But I could pick, say, the positive case. And we could say negative 4 plus 2 square root of 4 over 6. Yes? And it tells me it's negative 2 plus the square root of 34 over 3. It took that factor of 2 out of all three terms, yes? I mean, if I wanted to, I can come up here and say that this should be minus. We get the negative case for the square root, yes? So really all of this is saying that x is equal to negative 2 plus or minus the square root of 34 over 3. Because if there is that common factor in all three spots, both the top and the bottom, really it's going to be a common factor of 2 if there is one, then we can take it out. But if it's only in common with, say, the first number on top and the denominator, we leave it alone. Does that make sense? The calculator will tell us. And really, whatever we get when we reduce, we can put plus or minus there. Questions on this here? We ready for another? X squared minus 6x plus 4. What do we need to do first to get this equal to 0? It's already equal to 0. We don't have to do anything. A is, B is, C is 4. So we have negative B. So negative negative 6 plus or minus the square root of B squared negative 6 squared minus 4 all over 2 times. So again, the places where B showed up, we plug in negative 6. The places where A showed up, we plug it in 1. And the only place where C shows up, we plug it in as 4. Questions on this here? Now we can simplify. Here the negative negative 6 is positive 6. Our 2 times 1 is 2. Now we need to do negative 6 squared minus 4 times 1 times 4. Now do make sure to put the negative 6 in parentheses before we square it. That way it squares not only the 6, but the negative 2. And we get 20. Now the square root of 20 will simplify. 2 square root of 5. Questions on this here? The 30xs will tell us that also. 2 square root of 5. Now we can see if this does simplify because there's a common factor of 2 again, yes? Because we have 6 plus 2 square root of 5 all over 2 is?
All the 30xs.
Yeah. Square root of 5 plus 3, or 3 plus the square root of 5. If we look at the negative case to simplify, plus 3 or 3 minus the square root of 5, it's really just telling us x is equal to 3 plus or minus the square root of 5. I will take the 6 plus or minus 2 square roots of 5 over 2, but I would prefer it in simplest form.
This literally just seems like the same thing.
Yeah. And yesterday and today are the 2 ways that solve or work every time. Questions on this here? Are we ready for the next one? What can we do to get x by itself? Add 7x. Now this will tell us that 2x squared plus 7x plus 4 is equal to, what is A, B, C? So negative b, so negative plus or minus the square root of 7 squared minus 4 times a times all over 2 times 2. Now our negative b would be negative 7. Well, our negative 7 is negative 7. 2 times 2 is 4. Inside the parentheses, we have 7 squared minus 4 times 2 times 4. 7 squared is, let's go on and just see what the square root of 17 is. That's it. Questions on this here? Are you ready for the next one? We just need to get it equal to, so we can 5x squared from both sides, which tells us 0 is equal to negative 5x squared plus x plus 8. So a is negative 5, b is 1, c is now, do we necessarily have to write out A, B, C every time? No. If it helps you to see what A, B, and C are, do it. You don't have to. We plug 1 in for B, so negative 1 plus or minus square root of 1 squared minus 4. A is negative 5 and C is 8, all over 2 times A, which is negative 5. Now our negative 1 is negative 1. The denominator, 2 times negative 5 is negative 10. In the calculator, we can do 1 squared minus 4 times negative 5 times 8, which is, let's go on and take the square root of 161, see what we get. Questions on how we got to this here? Now, we don't normally like leaving a negative in the bottom of the fraction. So to fix that, what we're going to do is we're going to take that negative and distribute it through the top. So x is equal to, the 1 will become, the 10 in the denominator will become positive. And it would indeed actually be plus or minus. Because when we distribute that negative 1 or that negative into the plus or minus, the plus becomes minus and the minus becomes, yeah, because the plus became minus and the minus became plus, which gave us plus or minus. That's it. Now, if we notice that the first term, the a value will be negative, what we can do instead is divide everything by negative 1 to make a positive so we don't have that occur. Questions on this here? Do we like this better than completing the square? I mean, they're about the same. I mean, different way to solve it. This technically has a few less steps, but it's about the same. Here, 25x squared minus 8x equals 12x minus 4. So as we saw, having a be negative makes things a little tricky, not a whole lot, but a little bit. So if we can keep it positive, that will be best. So getting this to 0, what can we do first? We can add 4. 25x squared minus 8x plus 4 is equal to 12x. What's next? Not just 12. 12x, yes. So we still have 25x squared minus 20x plus 4 is equal to 0. Questions on this here? A is, B is, C is 4. Now, how do we feel with this so far? We feel comfortable with this, yes? So the first thing is negative b, yes? Well, what is the value b? It'd become positive, yes? And again, when I do this, calculating that, I feel fine with plugging that in. And if you feel fine with plugging that in and doing the sign change, you can do that. We can say it's going to be negative 20, which is just 20. The denominator is what? 2 times a. So those two, if you feel comfortable with doing that, you can do that. We can do those two. Because when I calculate it and I do these, those are 2 calculations I do as I'm plugging in. Changing the sign with b for that first part, negative b, we can flip the sign. 2 times a, whatever a is, we can multiply by 2. That's not a huge step. The one thing I do not do is with this here, I still plug it in. Negative b squared minus 4 times a times c. I still plug all of that in as it is. Because trying to do any of that all at once, that's a little too much. So now we need to plug in negative 20 squared minus 4 times 25 times 4. Did you put parentheses around your negative 20? Zero? What's the square root of 0?
Doing something.
Ah. Get another 5.
Oh.
So instead of 25, it was doing 255.
Oh.
Alpha y equals enter. Well, what is 20 plus 0? What's 20 minus 0? 20. It's still 20, yes? Adding or subtracting 0 doesn't. So the numerator is just 20 over 50. Does 20 over 50 reduce? So this is one where the graph hits the x-axis but doesn't actually cross. So we do technically have 2 solutions. It's just they're both 2/5. And that's it. green button, y equals enter.
Okay.
So we get 2/5. Questions on this here? We good with this so far? We only have one more of these that we're actually going to solve all the way through and find its values. And it's this one here. Now to get this equal to 0, we will minus 13 from both sides. Now it'll tell us that negative x squared plus 4x minus 13 is equal to 0. So a is -1. Yes? The last time we had that, we had to fix that sign change at the end. Yes?
So are we just
We can fix it now. So we can multiply everything by or divide it by -1. Because when we do this, it turns it from negative x squared to positive x squared. From positive 4x to negative 4x. And from negative 13 to positive 13. And 0 divided by -1 is 0. 0 is neither positive nor negative. Now that makes A 1, B -4, and C 13. And incidentally, if we did have a common factor of, say, 2 across all three terms for A, B, and C, at this point we could technically divide it out and it'll still work the same. Now, negative B, well, -4 is 4. Now again, if writing negative parentheses, -4 close parentheses, you need that to be able to see that, write it out. If you feel comfortable changing it to just 4, that's fine too. Or the denominator, 2 times A, 2 times 1 is 2. Do we feel comfortable with those steps? Inside the parentheses, we have negative B squared, or B squared. So -4 squared, not negative B squared, just 4 times A times C. -4 squared. -4 squared minus 4 times A times C is -36. So for the 30xs, if we had put this one in the calculator, not the calculator, inside the radical in this calculator, it would have thrown out an error because the 30xs will not do negatives inside of a radical. But the graphing calculator will do this one because 36 is a perfect square. Well, the negative, it would come out as, and what's the square root of 36? Because we could, in the yellow calculator, take the negative out as I, plug in the square root of 36, and let it simplify. 4 times 9, 36. Because square roots need to be number times itself. We get this here. Are both 4 and 6 divisible by 2? 4 divided by 2 is? 6 divided by 2 is? Now we could plug this into the graphing calculator because it is with I 4 plus 6 I over 2 is 2 plus 3I. 4 minus 6 over 2. Yeah. 2 minus 3I. So we get our 2 plus or minus 3I. Questions on this here?
I have one question.
Yes.
It's about, like, when you're subtracting a number, sometimes you put it up front and sometimes you put it in the end. So how do you know?
When I subtract a number from both sides?
So the last one, so you subtract We've never checked
13, and I put it in the back. So when we order quadratics, we order it according to the variable's power. So here, x squared is the biggest. It goes first. X to the first, or x, is in the middle. It goes second. And the number without x goes last. So it's always x squared, x, constant.
the square you put that first.
Yeah.
Are we gonna have
Yes. For 3, 6, you'll more likely need that one, but yes. Okay? So whichever one you get, just put your Nia and then the number. So does that make sense, Molly? Now, if we had, say, x to the third, that'd go even front, because it's always order of powers. Yes. And then it also goes alphabetical order if we have powers. So if it was a squared and x squared, a comes before x, so it would go first. And all of that is according to number theory. Yeah. Number theory, there's a whole section amount dedicated to that. That's a key component. There are other parts to it, but that is one part of it. This is the last thing we're going to talk about, the discriminant. Now, the discriminant is just this part here, the b squared minus 4ac. Now, this is the part that's inside the radical, yes? So it is helpful in knowing kind of what answers we'll get. Because if this is negative, like the last one we got negative 36, it tells us that we will have less than 0, it's negative. Sorry, over here. If it's less than 0, it has two complex solutions, like we had the plus or minus 2i, or sorry, plus or minus 3i for the last one. We have our two complex solutions. If it's equal to 0, we have, and if it's greater than 0, we have two real solutions. It kind of tells us what kind of solutions we'll have. So we're going to look at 3 examples of this, and then that will be the last thing we do today. And homework. And luckily, this is the last assignment for chapter 3.
If I don't get this done, I'm done for because we have the test, and then no more, I can turn it in.
What is the value of A? B, C. So we're wanting to find the value of the discriminant. B squared minus 4AC is what we're trying to find. So we'll plug it in. So negative 6 squared minus 4 times 1 times. And at this point here, we can plug it into the calculator. Negative 6 squared minus 4 times 1 times 10 is negative 4. So that right there is the value of the discriminant. That's its value. So since it is less than 0, we do have two solutions, and they will be complex. I call them complex solutions because the complex number is our a plus bi, but the book calls them imaginary. That is the same thing. But if the value of the discriminant is less than 0, we will have two complex solutions. Because that negative 4 would be inside the radical, the negative would come out as I. We get these imaginary numbers, these imaginary or complex solutions. Does that kind of make sense how that works? Let's look at the next one. A is still 1. B is still negative 6, but C is 9. Well, if it's not equal to 0, we would need to make it equal to 0. Negative 6 squared minus 4 times A times C. 6 squared minus 4 times 1 times 9 is
So
0. So the value of the discriminant is, if it is 0, the number of solutions we have is, and it would be one real solution. Really, we could put one unique real solution, because there's still two solutions. It's just like the 5/2 or 2/5 that we got earlier. It's just that the two solutions are 2/5 and 2/5. We do have two, they're just not unique solutions. They're not different from each other. And the last one, A is 1, B is -6, C is,
so is it always 2? That's probably a stupid question.
no, for this one here, I just set it up
It's where we have all, like,
where we would have all three. This one actually works out to be 4.
oh, okay, so it's
So it is greater than 0. So we do have 2. So if it's less than 0, it's complex. If it's greater than 0,
2 real.
2 real. So if it's greater than 0, we have 2 real. If it's equal to 0, we have 1 real. And if it's less than 0, we have 2 complex. And that's it. Questions on this here? Do we feel kind of comfortable with this for the most part? Now, on the homework, this is all I'm asking for this part. So there are some that, so this here, 6 through 16 even, you're solving for the value of x. You're plugging it into the quadratic formula, solving for the value of x. 21 through 24, it's asking you to find the discriminant, the number of solutions, and types of solutions, because it says for all three. I'm just asking for the value of the discriminant, so like we did, because where we got -404 for each one of those. The number, I'm really looking for 1 or 2, either 2 real, 1 real, or 2 complex. And that's all I'm looking for. If you look at the selected answers, or find the selected answers for this here, it does include the solutions. I'm not looking for the solutions. I'm not asking for the solutions for 21 through 24. I'm just asking the value of the discriminant, number of solutions, either 1 or 2, and is it real or complex?